Some say the world will end in fire. Some say ice. Or will it be an asteroid? AI uprising? Nuclear warfare? A crop famine? A plague? A solar flare? Some unprecedented thing we never even thought of. It seems like humans are obsessed with pondering the circumstances of our own end. And it's not as though human extinction is a far-fetched idea, really. After all, 99.9% of all species that have ever lived on Earth have already gone extinct. So the real question isn't if humanity ends, it's how. And humans have imagined almost every possible answer. Now, there's a difference between extinction, functional extinction, and societal collapse. Extinction specifically is defined as the complete termination of a species, occurring when the last living individual of that species dies. It renders the species permanently gone, as there are no biological means to bring it back. Something like even a nuclear war might kill billions without technically making humans extinct, more likely leading to the other two. Societal collapse is the rapid, substantial loss of an established level of socio-political complexity and collective capacity. It's a scenario where many of the systems holding society in place, governments, healthcare organizations, food distribution systems, can no longer sustain their basic organization or meet the fundamental needs of a population. Societal collapse would likely lead to mass casualties, as many people would lose reliable access to food, protection, or life-saving medical care. Functional extinction is when a species' population drops so low that it no longer plays a significant role in its ecosystem. Even though some individual members of the species survive, they can no longer reproduce effectively, or their numbers are too small to maintain their place in the ecosystem. In humans, this would look like birth rates plummeting due to extreme stress, malnutrition, or environmental strain. The few surviving human communities would experience severe genetic bottlenecks and inbreeding depression, making the population unviable. To avoid extinction from genetic defects, humans would need a minimum population of 140 reproductively healthy individuals. And like I said before, humans have a lot of theories about how our decimation might happen. These are ways that people, through mere ingenuity, hubris, or plain curiosity, create the means of our own destruction. Nuclear war is where nations use nuclear weapons as an offensive tactic against one another. These are weapons that release tremendous amounts of destructive energy through nuclear fission or fusion. This is a scenario that would have devastating effects, both in the immediate onset and long term. A modern nuclear weapon generates an explosion that can reach up to 100 million to 300 million degrees Celsius. That's about 4 to 5 times hotter than the sun's core. This immediately vaporizes anything in the immediate area. The initial blast alone could kill hundreds of thousands of people in and around the drop zone, but even greater casualties would occur in the hours, days, and even weeks following the explosion. Radioactive debris carried by wind would be blasted into the atmosphere. These debris would eventually come back down in an event known as fallout. This can cause radiation sickness to people far outside the initial blast zone. A nuclear winter also becomes a possibility if millions of tons of smoke and ash shot into the sky block out the sun. This would cause global temperatures to drop drastically. The abrupt climate disruption and agricultural failure would result in widespread starvation that could threaten billions of lives across the globe. The closest example of the level of destruction nuclear weapons are capable of was in the 1945 atomic bombings of Hiroshima and Nagasaki, when the United States dropped 2 atomic bombs days apart in both Japanese cities. 140,000 people were killed in Hiroshima. 74,000 people were killed in Nagasaki. In the years that followed, many survivors suffered terrible side effects from the radiation, including cancer and leukemia. These were the effects of 2 bombs. Today, 9 countries in the world possess nuclear weapons: Russia, the United States, China, France, the United Kingdom, Pakistan, India, Israel, and North Korea. Together, these nations possess an estimated 12,000 nuclear warheads, with Russia and the United States making up around 90% of the global total. As of 2021, the probability of a nuclear war stands at around 1%. The idea of mutually assured destruction standing as a strong barrier. A country is highly unlikely to deploy nuclear weapons against an enemy because of the likelihood of retaliation, which would result in the complete annihilation of possibly everything. In the 1% chance that an all-out nuclear war does happen, climate studies estimate that roughly 5 billion people would die within the first 2 years. An engineered pandemic is a global disease outbreak caused by a pathogen such as a virus or bacteria that has been artificially created or genetically modified in a lab. Because of their synthetic origin, these pathogens may have specific traits that make them more lethal, transmissible, or vaccine resistant. A global pandemic of this nature could derive from an accidental lab leak or as an intentional act of biological warfare. As of today, there is no proven historical or scientific evidence that a pandemic has ever been caused by an engineered virus, although widespread conspiracy theories do exist. There have been several claims that the COVID-19 pandemic was orchestrated by various different entities to further their own personal cause. Top targets of these theories include the deep state, big pharma, and billionaire Bill Gates. But in the event that an engineered pathogen was created to wipe out all humans, it would need to pass a few prerequisites. The pathogen must be airborne, highly contagious, have a long incubation period without symptoms, and boast an extremely high fatality rate. Thankfully, as of right now, no known pathogen checks all of those boxes since viruses usually trade lethality for transmissibility. Even viruses like Ebola or Marburg, which kill up to 90% of their victims, are still physically limited by requiring direct fluid contact. But if they were able to be genetically modified for airborne transmission, the effects could be globally devastating. But for a pathogen to truly drive humans to extinction, it would need to overcome both modern medicine and reach remote populations, which is still highly improbable. At least, for now. AI, or artificial intelligence, has seen an incredible amount of progress in the last few years alone. The general public now has access to computing software that can serve as a highly capable personal and professional assistant, from processing massive datasets, automating repetitive tasks, to even filling the place of a friend and therapist for some people. There is also a growing concern as to what happens if artificial intelligence gets a little too intelligent. Some even claim it may bring about the end of humanity. It's an idea explored in many sci-fi books and movies, a hyper-intelligent AI that destroys humanity, not even for malicious means, but simply out of plain logic or indifference. The ant scenario for artificial intelligence is a philosophical thought experiment that asks, if artificial superintelligence surpasses human intellect, will it treat us the same way that humans treat ants? That's to say that this superintelligent AI may not hate humans, but its goals may just consume massive planetary resources and destroy our habitats the same way humans pave over an anthill to build highways. Now, the type of AI capable of such world-ending power would be artificial general intelligence, as opposed to the artificial narrow intelligence we have access to today. AGI still remains a product of science fiction, although it looks like a possibility more and more every day. Hopefully, if it ever happens, our AI overlords will be benevolent leaders. Ecological collapse refers to the point where an ecosystem deteriorates to such a degree that it can no longer sustain its native biological community. This would result in a massive loss of biodiversity, clean water, fertile soil, and agricultural production. Because ecosystems are highly interconnected, collapse is often a multi-step process. Chronic stressors such as pollution, warming, droughts, and wildfires slowly push ecosystems to a tipping point. Although not at a critical world-ending scale as of yet, ecological collapse is an increasing threat as observed in coral reef bleaching, increased intensity and frequency of extreme weather, and forest destruction. Ecological collapse is the primary driver of all recorded major mass extinctions, usually triggered by massive environmental shifts. The most extreme example was the Permian-Triassic extinction event 252 million years ago, known as the Great Dying. 95% of marine life and 70% of land vertebrae were permanently wiped out. While a precise probability of global ecological collapse is improbable, many major ecosystems face a heightened threat due to human interference. But even in the event of cascading crop failures, extreme natural disasters, and severe water scarcity, total extinction remains improbable, with the collapse of global civilization the more likely scenario. Nanotechnology is the science of manipulating and controlling matter on a molecular scale between 1 and 100 nanometers. It operates directly at the level of individual atoms and particles, a scale thousands of times smaller than a single human hair. It's a technology already integrated in many industries, such as targeted vaccines, electronics, and everyday materials like scratch-resistant lenses and water-repellent fabrics. Nanotech poses existential risks that some researchers and ethicists see as capable of leading to human extinction. The gray goo nightmare is one hypothetical scenario where self-replicating nanobots consume all organic matter on Earth. It's a term that was coined by American engineer and nanotechnology pioneer K. Eric Drexler in his 1986 book, Engines of Creation. The threat lies in the mathematical power of existential growth. If self-replicating nanobots were to begin endlessly copying themselves using materials from the environment around them, they could spread across the planet at an alarming rate, consuming ecosystems, infrastructure, and eventually all organic matter, like a rapidly growing mechanical infection. The takeover could happen within days or weeks. But this nightmare remains mostly speculative science fiction since real-world nanotechnology faces enormous physical and engineering limitations. There are energy requirements, heat error rates, and material constraints. Even in the event that nanoparticles would replicate themselves, which is theoretically possible, scientists would likely catch the disaster in time to contain it. Asteroids are rock-like leftovers from the formation of our solar system 4.6 billion years ago. Some are hundreds of miles in diameter, while many more are the size of pebbles. Thousands of tiny debris from space enter the Earth's atmosphere almost every day. But every once in a while, as in every few thousand to millions of years, an asteroid finds itself on the fast track to Earth, an event that can cause devastating or even extinction-level effects. The last time an asteroid hit the Earth large enough to cause a mass extinction was roughly 66 million years ago, when a 6-mile-wide asteroid struck the Yucatan Peninsula, effectively wiping out the dinosaurs. The impact of this asteroid was the equivalent to 4.5 billion Hiroshima atomic bombs. And in the event that another one found its way to Earth, there's really not enough preparation or human innovation in the world that could save us. Upon impact, the asteroid would vaporize and instantly obliterate everything within hundreds of miles. There would be wildfires across the globe, seismic shockwaves that would trigger massive earthquakes and volcanic eruptions worldwide. Enormous amounts of dust, pulverized rock, and debris would launch into the sky, which would heat the atmosphere to the temperature of an oven, causing any surviving vegetation to burst into flames. Dust particles would linger in the air and block out the sun for years. The Earth would plummet into a nuclear winter as the food chain collapsed rapidly. Even the most prepared individuals who managed to get to a subterranean or undersea bunker in time would struggle to survive long term. though it is still possible with extreme determination. Scientists estimate that it would take an asteroid roughly 60 miles wide to literally boil the Earth's ocean and vaporize the crust. It's estimated that a planet-destroying asteroid occurs once every 10 to 100 million years. As of right now, there are no such threats hurtling towards our planet, but fortunately, or unfortunately, unlike the dinosaurs, we would see our end coming, since astronomers are constantly scanning our solar system for objects near or incoming towards our atmosphere. A supervolcano is thousands of times larger than a regular volcano. It's defined as any volcano capable of a magnitude 8 eruption in the Volcanic Explosivity Index. Eruptions eject at least 240 cubic miles of magma, ash, and debris. Unlike a regular volcano, which forms a tall cone-shaped mountain, supervolcanoes often look like a massive sunken depression in the ground. 74,000 years ago, humanity was almost wiped out by the Toba supereruptions. The eruptions ejected 672 cubic miles of volcanic ash into the atmosphere, blocking out most of the sunlight for years. The temperature plummeted. Acid rain contaminated water supplies. Countless animals and vegetation were buried in thick layers of ash. It was an extinction-level event, where the odds were extremely stacked against the survival of our species. It's estimated that in the years following the eruption, the global human population plummeted to fewer than 10,000 people. But the people who did make it out didn't just survive. They thrived and adapted. They adapted to changes in the environment and learned new ways to hunt for food. Around this time was when bow and arrow technology developed. Today there are about 20 identified supervolcanoes around the world that are monitored closely by scientists. They are classified as dormant and unlikely to erupt. In the event that a supervolcano like the one in Yellowstone did fully erupt, the continental United States would be blanketed in heavy ash. Agriculture would be destroyed. The power grid would collapse. The globe would plummet into a volcanic winter that lasted for years. But we would likely be able to anticipate it and prepare, at least to the level that it's probable all human life wouldn't go extinct. Just like 74,000 years ago, the humans far enough away from the eruption zone would survive, adapt, and reproduce. The course of history would no doubt change forever, but it wouldn't be the end. A solar flare is a giant explosion on the sun that releases intense bursts of electromagnetic radiation, energy, and particles into space. Most of these flares have no noticeable effect on Earth, but some, classified as X-class flares, are big enough to send their radiation all the way to Earth, possibly triggering blackouts, radiation storms, and interfering with satellites and power grids. This radiation travels at the speed of light, so its effects on the sunlit side of Earth occur within minutes. In 2003, a series of solar storms involving X-class solar flares interrupted satellite-based communications and caused an hour-long power outage in Sweden. But the most intense geomagnetic storm in recorded history occurred in early September of 1859 and became known as the Carrington event. The sun hurled a huge cloud of electrically charged particles toward Earth called a coronal mass ejection, or CME. When that wave slammed into Earth's magnetic field, it overloaded the planet with electromagnetic energy. At the time, the world's most advanced technology centered around the telegraph system, often called Victorian Internet, and it began failing dramatically a short time later. Telegraph wires sparked and caught fire. Operators received electric shocks. Some systems continued transmitting messages even after being unplugged. Auroras appeared so brightly that people could read newspapers at night in parts of the world. If a Carrington-level event happened today, the consequences could be far more dire because modern civilization depends on electronics and satellites for almost everything. The storm could overload power lines and transformers, which could lead to grid failures and widespread blackouts that could take months or even years to fully recover. In the meantime, supply chains would break down. Most food would rot without proper refrigeration. Millions would go without necessary medical care. banks and governments would likely topple as it became every person for themselves. This scenario isn't science fiction, it's practically inevitable, but as for when remains unknown. Scientists estimate the probability of such an extreme event occurring in any given decade to be between 1 and 12%. The hopeful side is that it's unlikely we would be caught completely off guard. Space weather agencies are constantly monitoring the sun using satellites that can provide a warning for such events ranging from hours to a few days. Grid operators would probably have enough time to adjust loads and safely take transformers offline to prevent failure. And many modern grids also have protective builds designed to trip when abnormal currents are detected. And in the event of the worst case scenario, at least the survivors would have a lot of time off work. A gamma ray burst is the most powerful type of explosion known in the universe. For a few seconds, a single burst can release more energy than the sun will produce in its entire 10 billion year lifespan. They're usually caused by catastrophic cosmic events like the collapse of a massive star into a black hole, the collision of neutron stars, or some other deep space phenomenon. When this happens, enormous jets of gamma radiation are fired outward at nearly the speed of light in narrow beams, like cosmic flamethrowers. Gamma ray bursts happen regularly throughout the universe, with astronomers estimating roughly 1 per day on average, but most are billions of light years away, effectively harmless to us. The real danger would come if one happened relatively close to Earth, or roughly just a few thousand light years away, and was directionally pointed at Earth. Radiation from a sufficiently close burst could severely damage, even destroy the ozone layer, flooding the Earth's surface with intense radiation from the sun. Ecosystems and agriculture would be disrupted, food chains would likely collapse, potentially leading to a mass extinction event. And unlike a solar flare, since a gamma ray burst travels at light speed, scientists have no real way of detecting it in advance. The deadly radiation and the visible flash would reach us at exactly the same time. But here's an interesting mind-boggling detail. If a gamma ray burst originated 10,000 light years away, then the explosion itself actually happened 10,000 years ago. The radiation would spend all that time traveling through space at the speed of light before finally reaching Earth. So if humanity were hit by one tomorrow, the star that caused it could already be gone, collapsed into a black hole, or completely transformed long before humans even invented writing. That means that a gamma ray burst is literally a blast from the past. You've probably had an experience where you were on a plane or in a theater and a baby started to cry uncontrollably. You may have rolled your eyes or quietly wished for the wailing to soon end. But what if you never heard that noise again? An infertility crisis is a hypothetical scenario where human birth rates fall so low for so long that civilization begins to collapse because there are not enough children being born to replace the population. Unlike asteroid impacts or nuclear war, this wouldn't look dramatic at first. It would slowly happen over generations. In the past few years, fertility rates have been steadily dropping on both a national and global scale. In the United States, fertility rates have dropped to a record low, about 1.6 births per woman, while the global average has fallen to about 2.2 as of 2023, almost half of what it was in the 1960s. But the dropping fertility rate has its pros and its cons. Teen pregnancy is down by over 80% since 1991. Lower fertility is directly linked to women's increasing access to higher education, career opportunities, and financial autonomy. Slower population growth also reduces pressure on global resources, potentially lowering pollution. Less children per family means that more resources can be allocated towards them. Lower fertility isn't necessarily the death sentence that some alarmists might have us believe. To a point. Imagine an extreme version of this scenario, where some kind of biological phenomenon or environmental contamination made humans almost entirely unable to reproduce. Older generations would eventually age out of doing all the essential functions that keep society running with no one to replace them. Economies would shrink. Governments and healthcare systems would deteriorate. Supply chains would break down. The end of the human race would be slow, sick, and utterly depressing. Antibiotic resistance happens when bacteria evolve so that antibiotics no longer kill them effectively. Drugs that once cured infections stop working because the microbes adapt and survive. This happens through evolution and natural selection. Every time antibiotics are used, most bacteria die. But a few that may survive because of random mutations or resistance genes multiply and spread their resistant trait to other bacteria. Over time, entire strains become extremely difficult or even impossible to treat. Human behavior that accelerates this process includes the overprescribing of antibiotics, using antibiotics for viral illnesses they can't treat, patients not taking their full course of prescriptions, heavy antibiotic use in livestock agriculture, poor infection control in hospitals, and global travel spreading resistant strains rapidly. These organisms are sometimes called superbugs. Resistant infections already kill over 1 million people worldwide each year. Before antibiotics, even minor wounds or common infections could become fatal. If resistance becomes severe enough globally, humanity could enter what some researchers call a post-antibiotic era, where infection we currently consider manageable becomes deadly again. But for a true extinction-level scenario to play out, multiple things would have to go wrong at roughly the same time. Other crises like war, widespread famine, or sudden infrastructure collapse would have to work in tandem to push humanity past the point of recovery. This category comes from religious and mythological traditions where disasters are interpreted as intentional acts by a divine force. Instead of random cosmic events, extinction is seen as judgment. Flood myths appear repeatedly across time, dozens of different cultures and religions. A Mesopotamian myth bears a striking resemblance to the biblical story of Noah's Ark and the Manu flood myth found in Hindu religion. Across all three stories, a man is warned by divine intervention about an impending flood that will wipe out humanity. He builds a boat to save his family and different species. It makes sense that flood myths permeate through many different cultures considering the integral role that water, specifically rivers, have in civilization. The earliest civilizations were built in close proximity to rivers. Rain and seasonal flooding was the difference between life and death. The dual nature of water is something that both sustains life and washes it away, makes it a hotbed for religious metaphor. Realistically, a global flood that submerges all of Earth's landmass is scientifically impossible, because there's literally not enough water in the world. Even if all the ice on Earth were to melt completely, and all the water vapor in the atmosphere were to instantly fall as rain, global sea level would only rise about 70 meters. Coast regions would be completely destroyed, but many continental interior and high altitude regions would remain untouched. Fire is another one of those elements that dances a fine line between life and death. It cooks our food, keeps us warm, offers sight and protection at night. Left unchecked, it can also burn out of control and turn everything in its path to ashes. Myths about a world-ending fire are imprinted within the cultures of various ancient civilizations. The relevance of this element across the collective unconscious seems to reflect humanity's shared awe of the sun, volcanic eruptions, and meteorites. Greek and Roman mythology tells the story of Phaeton, the son of the sun god Helios. Phaeton attempted to drive the chariot of the sun but lost control, scorching the earth, boiling rivers, and creating the deserts of Africa. He was struck down by Zeus before the earth was completely destroyed. In Norse mythology, Ragnarok, which tells of the end of the world, culminates with a great fire that sets the universe ablaze before the world sinks into the ocean and later rises anew, cleansed, and fertile. The surviving gods reunite, and 2 human survivors repopulate the earth. Plague is one of the oldest and most deeply embedded extinction fears in human history. Before germs were conceptualized, before microscopes, and before people understood how disease actually spread, illness appeared completely invisible and random. It arrived without warning, moving through families, villages, entire cities, and there was little anyone could do to stop it. Across cultures, plague wasn't interpreted as biology, but judgment. In the biblical story of Egypt, a series of escalating plagues is used as a form of pressure and retribution. In medieval Europe, waves of the Black Death were often framed as punishment for sin or corruption. But the reality is that plagues don't target morality, just biological opportunity. Different cultures throughout history have told their own rendition of the day that the gods, or God, see to the complete destruction of the entire world or universe. Christians call it the rapture. Norse mythology calls it Ragnarok. Zoroastrian belief tells that time itself will move toward a final purification where chaos is removed and order is restored. In some versions, humanity is divided and judged, with some deemed worthy enough to remain. In others, the world is entirely made anew. Judgment Day is less about the method of destruction and more about the meaning behind it. Psychologically, unlike asteroid impacts or pandemics, it offers something those scenarios simply can't: a sense that chaos is not meaningless. Religion itself rose from people trying to explain the unexplainable, to find the answers to questions people are still asking today. Why do some people die while others live? What is death? Will I be compensated for my good behavior? Will I be punished for my mistakes? On Judgment Day, even extinction would have structure. There are the things we know. There are the things we know we don't know. Then there's the largest category. The things we don't know we don't know. That is where the Black Swan event exists. A catastrophic event so rare and outside conventional expectation that humanity fails to recognize the danger until it's already begun unfolding. After all, before the discovery of black swans in Australia, Europeans believed that black swans were impossible. The phrase itself became shorthand for a truth humanity repeatedly forgets. Just because something has never happened before doesn't mean it can't. The interesting thing about extinction theories is that they reveal more about us in the present than they do about the future. With all the various apocalyptic scenarios that exist and the different eras of humanity imagining apocalypse differently, one through line remains. Humans will always be, to an extent, at the whim and mercy of nature. As a species, we aim to conquer, and we often do. In the past 300,000 years, we have tamed fire, risen to the top of the food chain, even walked on the moon. We are highly adaptable, resilient, and resourceful. But we're still just human. A latest adaptation in life's little game. Most of the systems we rely on, our technology, our infrastructure, even our understanding of risk, they're built on the assumption that the pattern we see today will continue tomorrow. But extinction may not come from what we already understand, and nature won't wait until we do. Perhaps somewhere out there, deep in the vast universe, hundreds of thousands of years into the future, a distant civilization is observing the final moments of a planet once called Earth. A brief explosion of light, caused by the collapse of a world that believed it had more time.